In this movie, we're gonna think about section 5.5, fixed cost part. Up to here, we assumed level of care or cost of care enters as variable cost in firm's problem. What if care cost becomes a fixed cost? So this is the question here. And it turns out when care cost becomes a fixed cost, the problem becomes quite complex to analyze. So we're going to take a look at this situation here. First, let's think about finding social optimum. So think about social welfare maximization problem. So previously, social welfare maximization problem was, remember from our previous analysis, this was a social welfare maximization problem. So to maximize social welfare, we have to find optimal quantity and quality. So this is social welfare maximization problem. And if you look at this problem, care cost is here. So this is care cost per unit. So if you calculate total care cost, it is Q times X. So this is Q times X, this is total care cost. And if Q is equal to 0, then total care cost becomes 0. So in other words, in this formulation, care cost is a variable cost in firm's production process. What if care cost becomes a fixed cost? So in other words, even when firms produce nothing, we have to pay care cost. So here we assume this formulation. So now care cost is here. So here x now represents total care cost. So even when Q is equal to 0, this total care cost can be positive. So now in this formulation, care cost enters as fixed cost in firm's problem. So in this case, this is a social welfare maximization problem. So let's find the social optimum. So first, take derivative with respect to quality x. Then we find this equation, and take derivative with respect to quantity and set it equal to 0. Then we get this equation. Now, one thing we can notice here is in our previous problem, this first equation was this red equation. So from this equation, we can find x star. But now, we cannot do that anymore because if you look at the first equation, we have both variables in the first equation. So you cannot just find x star from this equation. So using combining these two equations, you can find x star and q star. So from these two equations, we can find x star and q star. And remember, we have to calculate the social optimum again because this social welfare maximization problem itself is now different when we assume care cost is a fixed cost now. So we have to calculate social welfare problem one more time. So here we can find is that now X star and Q star, they are interdependent to each other. When cal cost was variable cost before, we can just find X star from the first equation. So X star did not depend on quantity, but now quantity depends on quality and also quality depends on quantity. So they are interdependent with each other, and this is the source of difficulty and complexity in this model. So when cal cost enters as a fixed cost to the model, it becomes quite complex because of this interdependency between quantity and quality. So when cal cost is a fixed cost, now we want to get X star and Q star that satisfy these two equations. So this is our target now. And let's suppose let's think about monopoly and no liability situation. So let's think about monopoly. In particular, let's think about no liability situation. Let's think about consumer's problem first because we need the inverse demand in monopoly. So consumer wants to maximize their payoff, and consumer's payoff is they obtain utility, and this is expenditure, and for each unit there is accident, and in that case they have to pay H. Because of no liability, we have this term in consumer's problem. So consumer wants to choose how much to consume. Then let's take derivative and set it equal to 0. We get this expression. So this is demand. So we can turn this demand to inverse demand by having price in left hand side. So this is our inverse demand function. And again, you can verify that if you draw demand curve, it's going to be downward sloping. If you take derivative here, so take derivative with respect to Q, we can verify that slope is negative. So if you draw demand curve, it's going to be downward sloping. Now let's think about monopolist problem. So let's think about monopolist problem. Monopolist wants to maximize profit. So profit is revenue PQ minus cost. Now cost is for each quantity, it has to pay C dollars. So this is a marginal cost of production. And cal cost now enters as fixed cost. And we don't have to worry about liability cost. So this is monopolist profit expression. So if you look at monopolist profit expression, this is revenue, and this part is production cost. So this is production cost, and this is cal cost, and in particular, this is fixed cost. So now cal cost is fixed cost because even when quantity Q is equal to 0, X cal cost can be positive. So this kind of fixed cost can be thought about as, for example, if a firm makes a R&D center, let's say, so to improve quality, there is a firm, and this firm built a R&D center. So it spent a huge cost to build R&D center, and even when this firm does not produce anything, it has to spend money to operate this R&D center. Let's say. So it already rented a building. In that case, it has to pay rent regardless of its production process, for example. So we can imagine this kind of carry cost is a fixed cost for this firm. Then this nominal price cannot be just a constant number, as we know by now. So using inverse demand, we can replace then monopolist problem is this is inverse demand. So this term is revenue part, and this is production cost and carry cost. So this monopolist has to choose optimal quality and optimal quantity to maximize its profit. So we can take derivative. So let's take derivative with respect to x. Then we get this expression. We can notice that this blue equation is same equation as we find here. So this first equation is same here and here, but we cannot say because this equation is the same, quality is same or quantity is same. We cannot say that because if you take derivative with respect to Q, so take derivative with respect to Q and set it equal to 0, we get this equation. And we can see that this equation, this green equation is different. So if you compare these two equations to these two equations from social welfare maximization problem, first equation is the same, but second equation is different. So therefore, because here we have to combine these two equations to find x and q, one equation is different, then the solution is going to be different. So from these two equations, we get x hat and q hat, and this solution is going to be different from this solution from social welfare maximization problem. So therefore, so in this case, we think about monopoly and no liability, and it turns out that the result is quite different from what we saw before. In section 2, we thought about monopoly, and there no liability and strict liability didn't make any difference. But here, when carry cost enters the model as a fixed cost, I forget about what I said for 1 minute. So here we thought about monopoly and no liability, and you can compare what's gonna happen under strict liability. So it is homework. So here I showed what's gonna happen in monopoly and no liability. And in the homework 5.4, you can do what's going to happen under monopoly and the strict liability. So try and you can compare them. So anyway, so the point here is we know that from the previous analysis in section 5.2, we know that monopoly output is different from social optimum. That's what we saw. But there, in 5.2, we could get optimal quality X star, but that's not possible anymore. Why? Because of interdependency between quality and quantity. If quantity is suboptimal, it's gonna influence care because of interdependency between quality and quantity. So therefore, if quantity is suboptimal, we're gonna get suboptimal quality as well. So when care cost enters as fixed cost, it's very difficult to get social optimum. So this is about fixed cost part. So as I said, in homework 5.4, you can do yourself about monopoly and strict liability, and you can see if there is any difference between no liability and the strict liability.